This is a demonstration for the solution of quiz 3. First, we'll go to the formula card and copy our formulas for convenience over to the sheet that we'll be working on. The first formula we need to use is for return. This is something we've done many times and practically everyone got it correct. I think it's best to copy that formula to the right and then select both and double click to copy down. I like doing it that way because I only have to type the formula once and then I can double check the accuracy at random places in the table. And I like being able to double click because if I had thousands of rows it wouldn't matter, it would copy them all the way down. Okay, next we will calculate the average returns, variance, and standard deviation. And again, copy them to the right, double check the accuracy, and it will minimize errors by not typing those formulas more than once. We'll add the covariance. And now we've completed step 1 and step 2. Step 3 is to complete the table. A few of you actually typed in values in column H, but it's always better to use a formula when we can. Now we know by definition that the risk-free asset has 0 variance and 0 standard deviation. We also know that the square root of 0 variance is 0 for the standard deviation. And we're told in the problem that the return on the risk-free asset is 1%. Now we've already built the formulas for 1 minus the weight of Kellogg for variance, standard deviation, and return. So let's just copy them from any line in the table down to our portfolio. Then when we guess a value for Kellogg stock, our portfolio calculates the value for ExxonMobil for the variance, the standard deviation, and the return of the portfolio. And we could double check this. I happen to have 50-50 up. I could go to the table and check 50-50 and make sure I get the same answers. If I don't, that's a red flag immediately. Next, we know that the Sharpe ratio is composed of rise over run, where the rise is the additional return that our portfolio provides above the risk-free rate. The run is the additional risk of our portfolio above 0 risk, so we won't even bother subtracting 0. And then we simply take the ratio of those two. We can go ahead and create the data for the capital market line in the next section. We know that it is the risk of the risk-free rate and the risk of our portfolio plotted against the return of the risk-free rate and the return of our portfolio. And I've already provided the extrapolation numbers for you. Let's go ahead and draw the chart now by highlighting the risk and return, insert, chart, and then we can add the capital market line by highlighting these 6 cells, Control C for copy, choose the chart, paste special, These are new series, and the category X values are in fact in the first column. Even though it looks like it, those lines are not tangent, so we want to use solver to maximize the Sharpe ratio. Set the Sharpe ratio to a maximum by changing the amount we invest in Kellogg. Say solve and OK. And it optimizes the portfolio at just over 36% Kellogg, and the remainder goes into ExxonMobil. I'll go ahead and show extra decimal places there just to show that they do in fact add up to 100. Next, we have 4 questions to answer. The first is, if we had $100 to invest all in stocks, how many dollars would we put into ExxonMobil? We would put in 63% of $100, which is $63. Now, if we first put half of that $100 into Treasury bills, that would leave $50 remaining for equities. 30% of our equities goes into Kellogg. Therefore, $18 and about 35 cents goes into Kellogg. In part C, if the risk-free rate were 12% instead of 1%, how much Kellogg would we want to own? The answer I'm looking for here is, if the risk-free rate went to 12%, what would be the tangent portfolio? And I chose a very high number, 12%, so it would be obvious by inspection. But let's zoom in on the graph and play with this a little bit. Just for illustration purposes, I'm going to draw a line by hand. You should never do this in a test or a quiz, but I'm going to draw from the risk-free rate with zero return to the efficient frontier. So we could be anywhere along that efficient frontier, and we want to maximize our Sharpe ratio, which means we want the highest slope of this line. And clearly in doing so, we are going through 100% ExxonMobil, 0% Kellogg. Now that is not a tangent point. If it were a tangent point, both the capital market line and the efficient frontier would have the same slope. However, it is the maximum Sharpe ratio, and therefore it works just as well as the tangent for us. So therefore we would put 0 into Kellogg, and any money that went into equities would go into Exxon. When I asked why, 2 answers I gave full credit for were 1, because it maximizes the Sharpe ratio, and 2, because I used my model and changed this to 12% and optimized with solver. And the answer it gave me was 0 Kellogg. I gave full credit for that answer, although I prefer the answer that talked about the Sharpe ratio and the capital market line. I'm going to erase this line for us now. An answer that I gave half credit for is that the return of 12% with 0 risk is preferable to a slightly higher return with significant risk. However, I only gave half credit for that because I don't know that we all know that 27% standard deviation is significant risk. If you can explain to me in your own words, come by and tell me why you know that, obviously by inspection, and I'll give you the rest of the credit if you missed half credit on that problem. But the answer I'm looking for is because $0 in K maximizes the Sharpe ratio. The danger with using solver in your model to see what happens with 12% is first, you may do like I did and forget to put it back to 1%. But second, you may actually run into an error, and some of you found that solver is not undoable. Let's take a second to look at data labels. And let's create some more descriptive data labels first to put on the chart. In fact, let's build a column for it and call it labels. And bear with me, we'll learn one step at a time here. The first step is a keyword called text. We're going to convert 0% to text, and we're going to say display that text with one significant figure and the percent sign. If you have questions about that, ask me about it. That gives us the 0% as a label, and we want that label so that we can add text to it. And the way we add text to it, the word we use is concatenate. We can use the ampersand and put in more text, in this case in quotation marks. So now we're showing that we have 0% in K, and I'd like to continue concatenating text, and this time show that we have some percent formatted with one significant figure and a percent sign, ampersand, double quotes, space, ExxonMobil. So that's a very helpful label on our graph. I think there's been a lot of confusion about which end is ExxonMobil and which end is Kellogg. So now we know we have built a label that looks at these two cells, or these two cells, to tell us how much is in Kellogg and how much is in ExxonMobil. Now we'll add the data labels as we've done in class. We will format the data labels to get value from cells, and in this case we'll choose those cells that we just created, and we'll turn off the Y value. And now we have data labels that show exactly which one is 100% ExxonMobil and which one is 100% Kellogg.